Welcome to the feedback for the C4.15 transition metals quiz. So first question, this was a good start. All of us got this right. So which of these is a transition metal? So we just need to be able to see where they are on the periodic table, and we've all clearly done that. So we've identified that copper is a transition metal. So sodium, we know from our work on alkali metals, is in group 1, aluminium is in group 3, and calcium is in group 2. So well done for that question. Question 2, what's the best description of the bonding in transition metals? So there's 4 types of bonding described here. So this first one here, electrostatic attraction between oppositely charged ions, is what happens in ionic compounds. So it only happens in compounds. So when we're talking about elements, you can't have ionic bonding. So it can't be the first answer. The second answer, which is the correct one, is electrostatic attraction between delocalized electrons and metal cations. So that's the description of metallic bonding. And so 7 of us, half of us managed to get that correct. So the third option, sharing electrons to give a complete outer shell, is a description of covalent bonding. And that, if we remember back to our work on covalent compounds or covalent bonding, it can occur in elements, covalent bonding, and in compounds, but it only happens with non-metals. So because transition metals are metals, you can't have covalent bonding in it, which also rules out the fourth answer of giant covalent. Right, question 3, which transition metal is used in catalytic converters? So there's no understanding here, this is just learning our key facts. So we need to know a few of the uses for the transition metals. So palladium is the transition metal that's used in catalytic converters. Of the other ones there, we should know that iron's used in the Haber process to make ammonia. We should know that copper's used in electrical wiring because it's a good conductor. And we should know that nickel's used as a catalyst for making margarine. Right, question 4, compared to group 1 metals, which of these is true? So most of us got the right answer here. So the correct answer is that transition metals are more dense. If we think back to when we saw in the lab the demonstration of the alkali metals, we should remember that they floated on water when you put them in, so they're less dense than you would expect more normal metals to be. Transition metals are softer. That's not true. If we think back to the group 1 metals, if you remember the demonstration, that I could actually cut them with a scalpel, so they were quite soft, whereas I wouldn't be able to do that if it was one of the transition metals like copper. Third option, transition metals are more reactive. Again, if we put something like copper in water, we know it's not going to do anything, it's not going to react, which is one of the reasons that we use it to make copper pipes for water. Again, if we think back to the alkali metals, when we put them in water, they reacted quite vigorously, and more so as you went down the group. And then the last one, transition metals are more malleable. That's just not true. Right, question 5. Which of these is not true for transition metals? So 10 of us managed to get this right. So they're often used as catalyst. That's one of the key facts from the lesson, so I'm glad none of us put that down. The compounds are often coloured. Again, this is one of the key facts of transition metals. It's one of their characteristic features. And they can have different charges on their ions. So again, this is one of the key points from the lesson. So they can have different charges on their ions. This is what distinguishes them from, say, group 1 is always +1, group 2 is always +2, group 3 is always +3, whereas the transition metals can have different charges on their ions, and this underlies a lot of the chemistry they have. So in the lesson, we talked about the typical properties of metals and the ones that transition metals had, and a typical metal property is that it's shiny, and transition metals are no exception to this. Okay, thank you for listening.